Hello, hello. Good day to you. Whether it's evening or morning, we're gonna spend some time on talking about exceptions and yeah, your PowerPoints are pretty involved, and I don't want to sit here and just drone on with PowerPoints. So I'm going to give some simple examples. We'll use it as a reference, and then we're going to get into actually doing it with your first assignment. So here's it. Just like, why are exceptions important? Well, because if we create a program, we want it to be error proof so that the process doesn't crash when we're trying to do something it shouldn't be able, or it's not able to do. And we want to continue with the program running. It's able to handle that error and continue the flow. And when I say flow, I'm talking about it's mechanical from line to line implementation as it goes when you're in your debugger, and I call that runtime code. So I'm talking about runtime code here that you want to check on, and if there is an error, you want to modify the flow of your program, the runtime, to catch that error before it processes. That's the whole idea. And anything from a divide by zero, or anything where or the file's not found, you can now also build your own specific input validation checks. But the idea is that we do it with control structures in a way where we can catch that error and move on. And so there's a standard for this. It's important to work with a standard of exceptions, and also to work with try catch statements so that you can try code out and catch any exceptions that happen with any of the libraries that you're working with. And that's where it's important is, hey, are we working with IO? Are we going to have those kind of exceptions? What kind of exceptions will be thrown by any library that we're using? It could be any object. And are we ignoring the exceptions? I mean, is it an exception throw that can be kind of ignored, like maybe a warning that it's a function that's outdated, something like that? That's usually what it is. But the idea behind everything is, let's keep the plane. If our program was flying a plane, how would we make sure that it doesn't kill 260 people? Okay, I'm getting morbid. Get away from that. All right, so Mr. B, you're being weird. Okay, yes, I'm being weird. But when we think about some of the stakes that come into play with the different systems that we rely on, it's high stakes. It is. So when you are working with production code, and I know you're just learning now, but when you have production code, there's a whole process where you bulletproof it. And there's a whole train of thought that anytime that you develop code, it should be treated as production code. So, what are exceptions? Well, exceptions are the ability to modify or change your runtime if an error is detected. So that means it takes your runtime code and changes it so that your runtime does not process things that should not be processed, because there's going to be a problem. Divide by zero, there's all kinds of different ways. Here's an example of the divide by zero exception that you can catch. And this is all for, exceptions that are already existing. And what you need is to work with a try-catch block where you try code, and the code that's inside the try block, you then have an adjoining catch block that can catch any error and outputs some kind of format, or it can catch multiple types of errors. Because you can have your try catch block where you catch multiple different exceptions that are possible within that try catch block. And that's just the way most modern code is built now, is with exceptions. And then that means that if you're building your own code, you are implementing exceptions. So here's an example of a try block, and you notice how we've got two different catches. So we can design our catch statements to catch exceptions from very general, or it's actually probably better to catch the exceptions from being very specific out to very general. So we can have a catch-all down here, another catch statement that just catches everything, that doesn't matter what the exception is. And then what we would do is make a choice on how the process would recover from that. Because what ends up happening is in this code, and let's think that, hey, we are running code that is not built by us. Somebody else built the integer.parseInt. That is a function that was built, and it was built specifically for Java, and it's part of the standard package that you get. So what we're talking about here is, hey, did we parse outside of the bounds of a substring? Because parseInt is converting some data, a number to a character or whatever. What kind of exceptions can happen based on working with that function itself? And so what ends up happening is, let's bring up this, is we got parseInt way down here. ParseInt, and we didn't create this. Somebody else did. We have our main up here, and when we call the parseInt function, it has its own lines of code, and it's looking to see if there's an error. So it's inside of an if block, looking at some kind of value, and if it returns true, it does a throw. And what a throw is it's direct manipulation of your runtime. It immediately moves your runtime to go somewhere else, so that you can decide where you catch it, because you're going to want to try and catch it down here or up here. You're going to do your try catch block up here, and the exception is going to be thrown down there. So that means that any lines after this throw that we detected that are going to be some kind of error don't get run. So these guys after that if statement don't get run, so your plane doesn't crash, because your runtime now changes to your catch block. And you can redo your try catch after that if you want to. You've recovered from the error. You've looked ahead and recovered from the error, and then you can go back to your input and make sure your input is correct, and ask for it again, even within a loop. So these are standards that when we build software, we want to allow the ability for your runtime to be modified back to a catch block, so that the mechanical line-by-line behavior of your code is modified so it doesn't crash the plane. And that's it. That's exceptions. It's that simple. The idea here, though, is that modifying your runtime code and what that means and what that looks like. So, I mean, we can get into it, because we're gonna have some fun here. We're going to get in and work on one of your assignments, and we'll see how far we get. This was, what are we actually working with on, this may be, I might change this. So if you're watching this video and the assignment's not the same, don't freak out. But what we're going to do is, it looks like we're going to have, and this is not going to be a Java FX program. We're going to create some kind of library that is used to look at document designations, and we'll look at the designation and throw an error whether or not it was designated as a UCP. So that means then that we probably want some kind of document checker object. And, you know, we're not going to tie this to documents, because we're going to take the document as a passed in function or a passed in variable. But what we're going to do is we're going to build it with a string that's going to be, we're going to simulate the behavior of that document checking for designation. And we would call it designation. We'll just call it designation type. That's what we'll do. And we'll send it we can send the string in the constructor and look at it and say, hey, is this a UC or P? If it doesn't fit the UC or P, we're going to throw an error. Okay, let's get into Java. What we're going to do is we're going to do this one. We're not designator. I don't know. I think that's good enough. Okay. Yeah, because we'll call the object designation check. And we're going to add that into the same package. And so I'm going to say new Java class here. And I'm going to say des check des. That's going to be designation. Check designation. That's a good enough object for it. And we can, this can be a really simple object where when we instantiate it, we actually send the name of the string that we want to check and throw an error. And then otherwise, what we would do is something else. Something that other than throwing an error, we would return possibly its status as a designation, and that could be a true or a false, which kind of implies that we want a function that checks it. We probably, because we want a return value, we don't want to use the constructor to check it, but we will create let's do two constructors. We'll do one that is default, and it is gonna just set the data that we're gonna have in here. And I know I need to probably make some changes here. This is the constructor, and I'll probably need to add some more stuff in there. We're going to have a private variable called str designation for the string designation. Now this could be the file name, it could be data in the file, but it's going to be the data that we're going to be looking at to determine whether or not we throw an error. And what we'll do is we will just assign that to string. Okay, I've got my whiteboard in front of me that's driving me insane already. Okay, let's get rid of that. We've already done some of the concept stuff. All right, we're gonna figure this out. And where are we at? We've got our constructor, our initial constructor. We've got some stuff to do there. Let's copy this. And let's do the overload, and this one's going to be string str designation. We're going to give it the same name because we can just use the this dot str designation equals str designation. Now we're just going to set the designation and allow us to be able to set the designation, but we're going to also build the function that will, let's make sure that all these are the same. Okay, so probably some silly errors that I've got. That's all right. You know, sometimes I got to put my Java hat on. Seriously, I mean, I know it might be like a cop out, but no, I mean, that stuff I'll figure it out later. We'll make some changes, and let's see. We've got the string going in. We've got, okay, now we're going to do a public bool check, and this is going to take a string str designation. This is going to be the main utility of the whole thing. And what it's going to do is it's going to look at the string, and if it contains, what is it? What was it? It was like, if it starts with U, C, or P. Well, that's simple. That one, what we can do is we can do something like this. If oh yeah, let's do that. We can, let's set a value here when it's been checked, or some kind of a value to that. No, because I'm just going to return true. We will assign empty quotes to it if it doesn't have a designation. That'll be simple. So this is going to look at the set designation. And it's only going to allow this to be changed if it starts with U, C, or P. At least I think that's kind of the direction it's going. But we will, we'll get the, else if, okay, if str designation of 0 equals U, or, and then we're going to just continue with that. And I think it's C. P. Oh, and you know what we should do is we should assign this to nothing at the beginning. Oh, you know what? I think I'm writing some Python because I'm forgetting some semicolons. Okay. All right. So everything's kind of good so far. I think I've gotten, let's finish up this if statement and then let's find out what we need to do with errors. And you know what I've started relying on because it's so hard for me to change hats? I've been relying on asking ChatGPT to fix it, or something like that. And that's actually an appropriate way to work with the AI. There's some software that I developed just the other day, pretty complex, just using ChatGPT to aid me and interpret. So it's oh, this needs to be P. Okay. I think that's all it is. Yeah, that's just the 2 or the 3. All right, so this is going to be 0. So whenever the first character in the designation, we would throw an error. This is where we're going to throw. Else, and this is going to be the code that's going to be allowed to run. And we actually don't even need the else. Because if we throw it, so that's just, if we throw it, we never get to this code. So let's just do this. we'll do this right here. We'll allow that to be changed. And then we will return true. Okay. All right, now what I'm going to do is I'm going to just look at all my little hoo-has. Okay, that's just a warning. Oh, string. I think I need to do this in capital S, I think. Yeah. With Java. Yeah. And does this need the capital B? Really? Okay. Let's just do this. Heck with you. I'm already sick of it. I'm already sick of it. Yeah. Come on. What's wrong with this? Then I'm going to Control V and put it in the code. And it works great. I love it. Okay, so we got key issues. Bool is okay, yeah, I knew I already did that. Oh, Boolean, okay, that's Java. You know, what else did I get wrong? Oh yeah, I was writing C code and I wasn't using char@. Okay, and then okay, so this one fixed those errors. So now I'm properly working with the way Java does things. Yeah, so evidently I was writing Visual Basic and C code. Thank you, ChatGPT. This is exactly what it's for. It's like a super Google. So, I mean, before when I would just, you know, hey, what are my references, you know, as far as getting started and what tool chain I'm using and what are the correct things, because there is a point where you've got so much going on in your head with different things that you want to rely on your references. And that's just what we need. Okay, so it looks like I need to refactor that so that it's a little bit more appropriate. Okay, so what does this do? Well, we don't even need to return false here because that will never get. But what we want to do is we want to throw an error. And let's go ahead and say, hey, ChatGPT, what would it look like if I threw if I added a throw, if I put a throw line instead of false? And it's going to remember what I did. And so we're going to say, oh, hey, what would it look like? Oh, okay. Illegal argument exception. So that's the kind of exception that we're going to catch. Now, you've got all kinds of standard exceptions. You can also create your own your own exceptions. And we don't need to return false because what's going to happen is that our runtime is going to come right back to return to sender. It's going to change the mechanics of our runtime. So this is what we're going to have instead. Let's grab that. Okay, going down here and have some fun. Let's go into, boop, 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 boop. There we go. All right, what are we going to change? We're going to throw instead. Let's throw that in there. Does that look good? Did I miss something? Yeah, I missed a closing. Did I miss a closing? Yes, I did. There we go. That goes to this, and that, you know, this kind of way of doing code just drives me insane. Put the stupid lines in there, especially when you're developing. You don't do that until you're done. Okay. So now we throw an error. So then that means, okay, we need to test it. We're throwing an error, and we need a catch clause to catch that particular error type. And it's just, the error is an exception object, And when you throw it, it's like a baseball being thrown back to you. Return to sender. Any of you guys that play Call of Duty and no, okay, never mind. I'm getting out of that because I quit playing games a while ago. Seriously, guys. Now let's test it. Now we're going to go in and we're going to test this object. It looks like we might have some errors in here. It's never used. That's not right. It's used right here. Oh, but this is not guaranteed to happen, so you will get your warning. Because of this, it's yelling at me and saying that it's not used, but even though I do use it. So we can ignore that happily. What we can do is just assign it equal to nothing. Do a literal. Oh, wait. No. They won't allow that. What we got to do is we got to make sure that is done. That will probably help it. Okay. Okay, yeah, that worked. Now we're going to go over to the check designation program, which is just our code, and we're going to test this. And we're going to say try. And then we're going to say catch. Now what we catch is going to be important. And also it's important that we have our brace blocks correct. So it looks like that one's good for the name, for the class. This one's good for there. Now it's yelling at me because of I don't have the catch clause, Oh, you know what? How would I write a try catch to test this? Okay, this is just better. All this information is available to you through Google with keywords and vocabulary. But this is so much better because the AI can interpret what reference you want. So I'm just I'm modeling, and I will model again with a proper use. But you see here how we've got catch and the illegal exception. So let's do this. Let's not just steal that. Come on, guys. But you know what we're going to do? Is we're going to catch the exception and call it E. We're going to grab this part of it. Just for testing. And we're going to demo it. I'm going to demo it and kind of what the behavior is here. But the idea is that when we catch, we're going to catch something. Now, yes, there is a way to catch all. I think I forgot the hoo-ha again. That hoo-ha. Okay. But we want to also be a little bit more precise in exactly what went wrong. And so when an illegal exception is caught of this type, then we want to add in exception. We want to say illegal designation refused. So in other words, the designation was not allowed to be set. Now, how are we going to test this? Okay, well, let's create a check designation object. Call it CD equals new check designation. And we're going to go with the default. Oh, maybe I'm using the name of the object wrong. Oh, I didn't include it. I didn't import it. Okay, yeah, all right. So that I can just go to fixed imports. Or I can just go up here and say import. All right, well, yeah. We have it in the same package. I don't need to import it. Let's see if we've got something that will actually compile. Okay. So we got no outputs. We got something compiling. Now what we're going to do is we're going to run and cause, because we're going to do a check. And what I'm going to do is I'm going to check on P designation P for professor. Okay. And then I'm just using the example of the AI put in, So the designation would be P for the professor. You know what? Let's make that, what would be the designation? I'm just going to make something up. What kind of company is this anyways? A business. Oh, it could be a project name. And it has to start with UC or P. Okay. Let's say that we're going to check the Manhattan project. I probably misspelled that. That's fine. That one should pass. And notice how I put capitals in there. You guys might want to do your two-upper there. Then I'm going to do another cd.check. And this one is going to fail. And actually, I want this one to happen first. And actually, I should just be copying this. Okay. I want the failure to happen first. Okay, let's say that they entered it. They're entering it, the designation, and they forgot something. And, maybe they've got some other formatting characteristics within there. We're going to be very simple. All we got to do is UC and P, I think. Is it UC and P? UCP. All right, whatever. We're trying it out. Okay, so this one's going to fail. This one's going to throw the error, and our runtime is going to skip over this line. It'll never get to it. It'll never get to this line if there's a failure here. And that's where you recover, because your runtime is going to change. It's going to immediately spit out, oh, you messed up, and you better have a catch for me or I'm done. Because then in the catch, you can put this in a loop, and in the catch, you can redo it so that you loop back up to where you ask for the input again that was incorrect, or some kind of error statement that will get the right input happening, so that we don't have a serious runtime error happening based on bad input. It's really that, that's what it is. Almost always some kind of input that's going to cause problems that you need to look at and check and make sure that it's appropriate before you move on. And it has to be done where you in a safe manner. So it has to be mechanical. The runtime code has to be thrown out. Like, we're messed up. Don't do anything more. And then, hey, we're flying. If we're all good, we're flying. No disasters. So let's check let's just look at what happens here. And I'm going to set a breakpoint. Let's see what I'm doing. Breakpoint, toggle line breakpoint. We're gonna go in here. I think I got to hit that button. Okay, yeah, there we go. All right, so we're going to witness how the exception is thrown. I'm going to do a step into. Oh, I did a step over. And something might have messed up. Let's see. How bad can this be? Okay, so I did the wrong thing. I want to do a step into. Okay, now when we look at the character at index 0, let's just see what this is looking at. I want to select this and add this to the watch. I'm going to copy it. Then I'm going to go over here and I'm going to add, where is my debug window? Oh, it's down here. Here it is. I've already got a bunch of crap in there. You know, this is all from my other watches. You know, it'd be nice if an easy way of getting rid of them, because they're all for different programs. So actually they do. NetBeans is kind of cool. Okay, we can look at this string designation, definitely. But I want to see what this is. So I'm going to enter that expression in to the watch, so I know exactly what my code is making a choice on. Okay, so let's hit enter. Okay, it's an M. Is that right? Yes, it is. So it should fail this. And you know what? This is a perfect example of why ChatGPT can't do everything. Because I think there's a logic problem here. And we want it to throw when it's not equal to UCP. Yes, see that's the beauty of it. Yeah, okay, cool. So we got, right now, this just passes through comfortably and saying, okay, you're okay. Continue with your runtime. You passed this test. And go back to your calling point. I'm returning true. Which implies that you might be doing an if statement here. But the throw is going to help you out if that if statement does, you know, you want to do it a different way and get the answer through the throw. But you may need some other processing if it returns true. And you need to know in this scope right here if it returned true or not, so you can do something so that you can then continue and exit out of that out of the checking area for this. So let's go and modify this because we want not equals. Because we already looked at it when it passes. Let's look at it, and I'm going to do Control S here. Let's look at it, run it again, step into when we fail. Immediately, we go to throw. And what it does is, like a baseball, the legal argument exception is the baseball. That object and the instantiation of that object. Notice how we don't give a name to it, but you can actually create your own instantiations of it and throw those instantiations. If I wanted to, I can create an exception up here, that object, and then throw the name of that object. But we are implicitly instantiating a whole new object here when I could go up here and I could say, you know, hey, T is equal to new exception and do a throw T instead. So, you know, I can create the object, you know, right here I would have this guy, you know, of course above for the type, and then I can do a throw T. But that, you know, hey, yeah, you may need something like that, but we don't need that. We can just do this. So we throw the illegal exception with the error, and this is the best way to do it. And the runtime is totally changed, and we immediately go, this line is never reached. It never happens. These lines never reached. It never happens. And so we're using the exception to modify our runtime. And it's a mechanical binding. And that's what makes it safe, and that's the importance of it. So when you need to foolproof your executables to fly a plane, I would highly suggest using these because they're going to be part of the testing sequence. So whatever platform you're on, they're going to implement exceptions because it has to be a mechanical link. And exceptions are how we modify the runtime code so that it's mechanically sound at catching errors. And that's the concept. And that's what I wanted to get across to you today. So if we change this to actually being one that passes, we step into, and we're going to walk through. Oh, wow, I'm lying to you, it looks like. What is it supposed to be? UCP? Oh. No, I'm using OR. If, did I mess this all up? Am I getting my logic wrong? Seriously? You're probably laughing at me if I did get it wrong. I can laugh at myself. Sometimes I got to see it out here like this. All right, so if it's a U, or if it's not a U, if it's not a C, or it's not a C, or it's not a P, you know, that kind of seems a little backwards. Let's make sure. Maybe I didn't build it all right. Let's do this. Oh, because okay, I want to test that. Oh no, I want to test this guy right here. We can actually just do this, yeah. Control S, run it. Okay, this one will throw the error, so that doesn't happen, okay? Then what we're going to do is we're going to make it so that it shouldn't throw the error with a P. And then we're going to look at that and see what happens. I could have written it all wrong. So let's do a step over. Okay, yeah, it's throwing the exception. So let me think about my logic here. Yeah, this is a little weird. I'm gonna rebuild this. I'm gonna make it so that it changed. You know, now that I've kind of demoed what happens when an exception is thrown with your runtime, let's just kind of fix this so that it's a little bit cleaner. You know, we only want to allow anything that starts with that in. So that means that we're throwing the exception in the wrong spot. That needs to be done here. But I wanted to show you what happens and how it can skip over lines. So that I've shown, you know, with the faulty logic. This is much better. You know, it looks at the first character, and if it sees a U, C, or a P, it's going to allow the designation to be changed and return true. And if it gets to the throw, that means that that if statement didn't happen because we return here. So that means that if it gets through this without going true and returning a true, if it does return a true, this never happens. But if it's false and it just says, oh, that's all false, it'll go down here and do our throw. Okay, now let's this is much cleaner. But hey, you know, demo is done. Let's get things working the way they should. All right, set a breakpoint. Debug. All right, this should pass without going down to the catch. And it passed. Okay, now that I got my logic right, this should fail and immediately take our runtime time down to the catch. And it does. Okay, so now we got everything working. And you guys, when you are looking at the assignment, make sure you read carefully and complete all the parts that the assignment is asking for. But this is kind of it was a good demo to get you kind of, to give you an idea of how exceptions are used to change runtime, mechanically recover from errors. And I use that mechanical word kind of loosely, but that was my goal for today. I mean, really, there's a whole bunch of PowerPoint stuff in there, and it boils down to just showing you how it works without boring you and droning on and on and on. Okay, guys, thanks a lot. Bye-bye.